Hello, my name is Brock LaMeres, and I will be your instructor this summer for EELE 261 Introduction to Logic Circuits. In this video, we're going to go over the course, read over the syllabus, and talk about the logistics of how you're actually going to accomplish the class. But before that, we'll talk about what this class is all about, and then I'll introduce myself as the instructor and the author of the textbook, and also the voice and hands in all the videos you'll be seeing. Okay, so let's start with what this class is all about. So this is it's a class that starts looking at the basic building blocks of a computer. So when we talk about digital circuits or logic circuits, we're talking about those that operate on values that are ones and zeros as opposed to an analog voltage that you might see in like an amplifier circuit. And so the design methodology is a little different than you would if you were doing something analog. And so we only mess around with ones and zeros. And so this class starts teaching you about how you interpret ones and zeros as numbers, how you manipulate them to represent information, and how you build circuitry to accomplish tasks that operate only on ones and zeros. Now, this class is about the hardware and it's about the low-level building blocks. So we are not going to be programming in C or Python or anything like that. What we're going to be doing is looking at the very low level, so the gate level, like the basic circuit, so AND gates and OR gates and things like that. And then we'll build up into more sophisticated circuits such as state machines and memory devices. And when you leave this class, you'll basically have an understanding of what is behind or what the circuitry looks like in a computer. You still won't know exactly what a computer is, but this sets you up to be able to take the next class, which would be logic design, where you'd actually be able to build the full logic hardware. We will be using a programming language. It's actually not a programming language. It's called a hardware description language called VHDL. And that's going to allow us to design more sophisticated circuits later in the class by using a language. So we'll start with pen and paper design, and we'll be designing, little circuits here and there and looking at number systems and all that sort of stuff. And then what we'll do is we'll transition into using VHDL, and we'll be able to model circuits in a tool and then allow the tool to actually synthesize the circuitry for us. And we'll get experience downloading our circuits onto what we call a programmable logic device. The course is going to be broken down into 7 modules. The first module is going to look at the difference between an analog and a digital circuit and the difference between the signaling types that we use for those. And then we're going to go into module 2, which is on number systems. So if we're going to be treating inputs and outputs as ones and zeros or binary, we need to understand how we can use ones and zeros to represent information. So we're going to look at how we represent numbers in different number formats such as decimal and how that translates into binary, and also learn about some other number systems such as hexadecimal in order to represent large numbers of binary circuits. And so we need to look at how the numbers are formed and how to convert between them, and even how to perform basic arithmetic. Then we move to module 3, which is on digital circuits, and that's where we start looking at the lower level gates that are used to manipulate digital signals. And we also start putting these down on a breadboard and looking at how they are actually circuits. So they do require a power supply and a ground, and you have to make sure that they can interface with each other. And then we move into module 4, which is on combinational logic design. So this is where we finally get to a situation where we say, I want to create a circuit that produces these ones and zeros when these ones and zeros are on the inputs. And so we'll take a functional description of a circuit, and then we'll figure out a way to, by hand, synthesize a logic circuit that we can actually build on a breadboard. Then we'll switch gears and we'll start learning about VHDL, which is the hardware description language I mentioned. And this is going to allow us to basically describe a combinational logic circuit and then use a tool to synthesize it or come up with the gates that you'd actually use to build that circuit. Then we'll move into module 6, which is on medium scale integrated circuit logic. And that's where we start looking at kind of larger combinational logic circuits like multiplexers and demultiplexers and decoders, and look at how not only you can build them with lower level gates by hand, but you can also model them with VHDL and allow the synthesizer to create the logic for you. And then we'll wrap up the course by looking at sequential logic, which is where we actually start building sophisticated logic circuits, such as finite state machines that can track past occurrences of various inputs by using the notion of a storage device to track where you've been. So before we get into the logistics of the class, you must be wondering, well, who is this guy who's going to be teaching me about these building blocks? So I am a professor of electrical and computer engineer at Montana State University. So I am physically located in Bozeman, Montana. And I got my bachelor's degree from Montana State back in the 90s. And then I went to work for Hewlett-Packard, where I designed electronic test equipment for 8 years. And I was a digital hardware designer. So I did FPGA design, printed circuit board design, acquisition system design. And so all of the circuitry that I'm going to be teaching you about is stuff that I actually use as an engineer in industry. And so this stuff is real. It's not just make believe. You will actually use this stuff. And so while I was working at Hewlett Packard, I decided to go to graduate school. So I went to, I got my master's degree at the University of Colorado in Colorado Springs. And then after that, I started teaching as an adjunct instructor, classes on embedded systems at University of Colorado in Colorado Springs. And after a couple of years of that, I decided that I really liked teaching and I really liked being an electrical engineer and a computer engineer. So I decided to go back to school and get my PhD. And so then I continued working and going to school, but this time I was going to school at the main campus, University of Colorado in Boulder. And so then after years went by and I ended up getting my PhD, and that allowed me to become a professor. So in 2006, I came back to Montana State, and I have been a professor now for nearly 15 years. And what I do is I teach and do research in the broad area of computer engineering and digital systems. And so I'm showing you my website right here just to kind of highlight some of the things that I do. So the classes that I teach are like introduction to logic circuits, obviously, both at the very low level all the way up to senior and graduate level, digital system design and high-speed digital system design. And then I do research on, using embedded systems to solve problems and also coming up with novel computer architectures for various applications. So my main work, if I come out to my research over here, my main work has centered around trying to exploit these programmable logic devices to create real-time adapting hardware that can recover from faults or give you better performance in real time. And so most of my work has been funded by NASA. I currently have a project right now where I'm building a computer that's going to go to the moon in 2022. I've got we actually have this computer that we've invented called RAD-PC that uses an FPGA and can react to ionizing radiation that causes a normal computer to crash. And so we've developed this computer and we're going to fly it, or we actually have 2 small satellites in orbit. One of them is called RadSat-U. This is a picture of it right here. This is its launch back in November of 2019. I'm standing in this crowd right here with my students watching that go off from Wallops Flight Facility. Here's a picture of it being pushed out of the International Space Station, so it's in orbit right now. We have a second satellite that's up there called RadSat-G, and these things are about the size of a loaf of bread. Here's its pictures of it. It's launched at night, being pushed off the International Space Station again. And then we do all sorts of other things like balloon flights to try to test this computer in various environments. We've had it on the International Space Station. Here's a version of this computer, RAD-PC, being installed by an astronaut. And then we've done everything from flying on sounding rockets to weather balloons. And so anything and everything to just kind of test that technology. So what my background brings is I have a degree, a PhD in electrical and computer engineering. I've also worked in industry using this stuff. And then I also do research that really takes what I'm about to teach you and actually implements it in applications that can kind of advance computing technology. Okay, so now let's talk about the logistics of the course. First and foremost, you are going to access all information for this class in a system called Brightspace. It is simply a website, but it's a learning management system that we'll be using. So you're going to go out to ecat.montana.edu, and it'll sometimes redirect to ECAT1, ECAT2, but just type ecat.montana.edu, and you're going to log in with your net ID and password. And so you should have received this as soon as you're an MS student or an MSU student. Okay, so when you come in for the first time or anytime, you're going to see the home screen right here, but then you're going to see a list of your active courses down here on the right. And lo and behold, here is our course, Introduction to Logic Circuits, EELE 261. I posted a welcome message as an announcement in here just to get your attention if you didn't notice this, but it gives you a little hello and it gives you a link that you can click here to go to the class, or you can come over here and go ahead and just click on the class itself. And so then that takes you to our main landing site here. So this is going to be where you log into every single time that you are going to do anything for the class. Okay, so here we go. The front page has, the welcome announcement right there. But then up here, you're going to see all the different tools that we're going to use. There's a lot of different tools we're going to use within Brightspace, but everything can be linked through content. So you can either click content right here, or you can come down here and click this to go to the first content page. But let's go to content and look at what's over here. I have put two things here, the course activities and supplemental learning modules. You don't worry about these supplementals until later. It's just a way to get extra practice in module 4 and 5. But if you look at the course activities, you're going to see all of the 7 modules are listed right here. And each one has a page with links on it. And then you have the course information and syllabus. So let's go through the course information and syllabus first, and then we'll go through the module. I'll show you what a few module pages look like. Okay, so here we go. We're in the course information and syllabus. This page is just kind of a quick summary of relevant information about the class, and also more importantly, kind of quick contact information. So if you need to find my email or our teaching assistant's email, you can come here and click on this as opposed to going to the full syllabus. But when you come down here, here is the full syllabus. So the first thing to do is click on that and it'll bring up a document. I'm going to come back to the web page and then just scroll down a little bit. So here's my contact information. Our teaching assistant this summer is going to be Stephanie Smith, and her email is given right here. We are going to communicate using email. Okay, so we will communicate almost exclusively with email, but when you get stuck on things, if you want to have video calls, we'll do video calls on it. And so since we're going to be using email, I have a little professional email etiquette guide right here, and I'd like you to read through that. And at the end of it, it'll ask you to send me an email. And if you read through that and you send me an email using the recommended format, I'll give you a little extra credit points just to kind of build up your account balance for your grade. So I'll give you 20 extra credit points, or 2%. I'll add 2% to your overall grade if you read through that etiquette guide. And that'll be cool. All right, so then the required material here is, number one, you're going to need a computer with high-speed internet. And here's the kicker right here. You need access to a computer with Windows. Okay, the software we're going to use for VHDL and our programmable logic device doesn't work on a Mac. And I'm sorry, that's it. Okay, it just doesn't work on Mac. So if you have a Mac, you either got to find access to a Windows machine, or you got to drop the class because it's not going to work. Okay. So that's the first thing. Second thing is you're going to need the textbook. So this is Introduction to Logic Circuits and Logic Design. That's by me. There's a second edition. If you have the first edition or you find a cheaper version of the first edition, that's fine too. Typically Amazon has the best prices, even more so than the bookstores. Okay, and then this is critical. If you're listening to this video and you don't know what I'm talking about when I say portable logic kit, that means you have not replied to my email. Don't go any further until you email me and tell me where to get you your digital logic kit. I am going to check you out a kit that you can do all the lab exercises remotely. And it's going to have a breadboard and circuitry, logic gates in there. It's going to have a portable instrument to power and do measurements. It's going to have a programmable logic device. And I emailed everybody in the class and asked you for an address to ship it to, or whether you're going to pick it up. So at this moment, if you have not seen those emails, stop and go look for them, or email me and say, what's the deal with this portable logic kit? Because you need this on day one, okay? And then finally, you need a camera capable of taking short videos. So just a smartphone, because the way we're going to demo our labs is going to be, you're actually going to build the circuit, and then you'll take a short video, less than 10 seconds of you kind of switching switches or watching the LEDs blink to show that it actually works, okay? So that's kind of the introduction. Let's go to the more sophisticated syllabus here. So each of the modules has a variety of learning objectives associated with that, learning outcomes. And so they're kind of what we talked about. Understand the difference between analog and digital systems, understand binary numbers, look at data sheets, synthesize combinational logic, use hardware description languages, build medium scale integrated circuit logic circuits, build state machines, and then yeah, and so just kind of an overview of the learning outcomes. Now, in terms of logistics for time and location, this is a 12-week summer session, and it runs from May 18th to August 7th, and it's fully online. Okay, so we will never see each other in person, but you'll hear me in videos quite often. Okay, and so here's the same information repeated. The prereq for this is just a course in algebra, so you don't have to have any prior electrical engineering experience with this. In terms of website, we already looked at that. Grading distribution, you're going to have 4 components to this class. You're going to have homework, labs, end of module quizzes, and exams. And there's 1,000 points possible in this class. And this is kind of the breakdown that you'll see. Okay, grading scale, I just do straight grades. 90 and above is an A, 80 and above is a B, 70 and above is a C. Academic policies. Now, this class is interesting because you're remote, but I know that a lot of you are, together, you live in the same dorm or you share the same house. And so here, everybody has to do their own work. That isn't to say that you can't work together and collaborate and help each other, but you cannot full out cheat. And what cheat means is that you use somebody else's work. Okay, if you work together on a circuit and you both create your own homework or problems, that's fine, that's collaboration. But when you violate the cheating policies where somebody does the work and then you turn in their work, so somebody writes a program and you upload it and claim it as yourself, that's not acceptable. Okay, so the academic policies are right here. And then here we get down to how are you actually going to do the class. So the first thing is that you have reading and instructional videos. So I wrote a book that the class was designed. We revamped this class to be modern and relevant and have a targeted set of learning outcomes. Then I went back and I wrote the book to match the class. And then I recorded videos to basically be another mode of communication for the book. So if you have the book and you're a reader, if you like to read, then you can read the book. Okay, so you'll read a section and then you'll do homework and then you'll do lab. Or if you'd like, you can do instructional videos. And so I have videos for every section within the book, or you can do a combination of both. So these represent right here, reading and instructional videos. That's like the equivalent of coming to lecture. Okay, so that's how you get the information. And there's examples in the videos and stuff like that. Then you're going to have homework. And homework is going to be either in the form of online quizzes that are multiple choice within Brightspace, or they're going to be simulations where you're going to design a VHDL file, simulate it, and then take screenshots of your output and then upload the simulation waveform and your files to what we call an assignment folder. So you're just going to upload it to Brightspace. And so these are graded, okay? And these are graded, and there's going to be weekly deadlines where multiple homeworks will be assigned. Laboratory, you are going to actually perform real laboratory exercises using the lab kit that I send you. You're going to demonstrate them by taking short videos with your phone and uploading the video or uploading it to YouTube and providing the video link. But that's how we're going to demo. It's not going to be a live demo where you video call me and I watch you demo. It's going to be you are going to record something. And in these videos, what I'd like you to do is always start with a picture of your face. And so you turn on the phone and say, "Hi, I'm Brock LaMeres. I'm demoing lab 2.1. Then you turn it to your breadboard and you show it operating. And that way I know that it's you and I know that you're okay and that your circuit is working. And then at the end of every module, we're going to have these quizzes. Now, these are kind of like exams, but there's 7 of them, and I'm just going to call them quizzes. These are basically summaries of the module, and they're timed. And so what I mean by that is that once you start them, you are only going to have a certain amount of time to complete it. So they range from 30 to 90 minutes, and they're to emulate what it would be like if you were a live class and you sat down and took an in-class exam. And so the big difference between like a homework and a module quiz is homework, you can open them, you can look at the quiz, and you can enter answers and save it and come back later. And it only vanishes when you either submit it or the deadline expires. End of module quizzes also have a deadline, and so after the deadline, they will be gone, but you can take them anytime. The key is that once you open them, a timer starts, and you have to actually complete the quiz before the time allows. And even if you log in, start it, and then log out, the timer keeps going. And after 30 or 90 minutes, whatever the time limit is, the quiz will actually disappear. Then the final exam is going to be an online Same thing as the quiz, it's just going to be comprehensive. And so at the end of the class, you'll take the exam and it'll be all multiple choice questions, and that'll be it. This is the most used resource for the class. This is the course schedule. Okay, so this shows you every single topic, every single point that goes to your grade, every single assignment, and every single due date. Okay, so when you come in here, you are going to have every single week, you are going to have a set of activities. I have set all the deadlines to be due on Wednesday at noon. So during week one, number one, you are going to have some assignments associated with the course logistics and analog versus digital module 1. They are all due on Wednesday the 20th. So that's why you have to have your lab kit right away, because it starts on a Monday and you have deliverables that are due on Wednesday at noon. From then on out, the weekly activities will be due the following Wednesday. So then the rest of week one, you're going to look at number systems, and then they'll be due the following Wednesday at noon. Week two, you're going to look at module 3. The deadlines will be due the following week, Wednesday at noon. Same thing with week 3. You do some of module 4. It's due the next Wednesday. If you look at the breakdown of what you actually do, this is very common. You're going to have homework problems associated with each section. So module 1 has 2 sections, 1.1 and 1.2. You're going to have a homework quiz. So you're going to do these homeworks and you're going to submit them and you'll get your grade instantaneously. And then you're going to do a lab. And the labs are worth a lot more because they're more involved. And so then you do your video and upload that, and then we will actually grade it and give you a grade. And then at the end of every module, you will have a module quiz, which is timed. And so this is how the entire class is just going to flow. It's just homework, homework, lab, quiz. Homework, 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 lab, quiz. Homework, 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 lab, quiz. And then as you get to some of the lengthy modules, we'll go homework, 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 lab, homework, lab, quiz. Okay. And then as we get down into, VHDL, you'll see that some of the homeworks turn into VHDL simulations. And I show that right here with these asterisks. And then you actually will get into laboratories that use the programmable logic device. And then you just repeat until you're done. And then when you're done, the last week of the class is going to be the comprehensive final exam. The only difference is the only deadline that's not on a Wednesday. It's on a Friday, and that's because the class ends that day, and it's Friday at noon. Let me tell you the rationale for why I always have a deadline at noon. It's because if you ever have a deadline that's outside of working hours, like midnight, what happens is that something will always go wrong that is out of your control. If you're working on your assignment at 11:55 p.m., the computer's going to crash, the network's going to crash, Brightspace is going to crash, your circuit's going to blow up, and there's nothing that we can do to help you because we're sleeping, okay? So I want all the deadlines to be during the workday so that you can, if something goes wrong right for the deadline, you can notify me and I'm aware of what happened. And that avoids the situation where you're just frustrated and you're just like, I can't get this working. And you just say, I give up. My circuit doesn't work. And then you lose points because you missed the deadline. And so that's why I always like to have it in the middle of the day. I don't like, the Wednesday just comes from, I want you to work on assignments for a week. And then it's like, well, when is it due? Well, of course you want the weekend. Okay. So, because you can work, a lot of people prefer to work on the weekend, but then it's like, when should it be due? Well, if I made it Monday at 8 a.m., that doesn't give you any time to work on the weekend and ask questions. So then it's like, well, we should at least have all of Monday to do it. And then it's like, well, what if you didn't get to it Monday? So anyway, there's really no good time for a deadline, but I have honed in on Wednesday at noon for this class. So that's just going to be what the deadlines are. Okay. All right. Learning outcomes and objectives. If you're kind of interested in the specific things you're going to learn, I have this massive table down here that shows you not only what you're going to learn, what you'll be able to do, but also the level of learning, whether it's knowledge, application, synthesis, etc. So let's go back and take a look through Brightspace and see how you navigate this. So I'm going to go back to here and notice that when you're on one of these pages, you can come back to content and find this page, or you can just arrow through them. But let's look at module 1, and it gives you a really good overview of what to expect. So you're going to come in here. I always list out the learning outcomes so you know why you're doing what you're doing. And then here's the activities. So you notice that there's 2 sections, section 1, section 2. Each section, like I said, has either a reading assignment or a video and it always has the of reading and video, and it's up to you whether you do both, one or the other. So it doesn't, whatever you prefer. And when you click on these, that's just a YouTube video that I created. So it's just me on there. And then when you come in here, so I mean, I can click on it here. So let me click on it. And so it just brings up YouTube. But here I am. Okay, so check this out. Here's a video, and let's take a look at it. So sometimes I'm actually on here writing, right? So you actually see my hand and I'm doing stuff. And so this is what the course is going to look like. You're going to be watching videos of me. You're going to be listening to videos of me talking and describing stuff. And then you can read about what's happening if you want. Same information in the videos we're reading. And that's what this is what's going to entail. You're going to be doing a lot of this to learn the information. And then you're going to do something. So if I click on homework 1.1, it brings open a quiz, and I'm going to have this quiz. And so if I start the quiz, I can save it and leave just as long as it as long as I complete it before the deadline. And here's the type of questions. What part of any system will always require an analog component? It's like, no, what is it? What is it? Well, it's like, maybe I'll do that one. And so you just fill that out. And then when you get down here at the end, you can either submit it, or at the top, you can close it, and that will not submit it. Okay, it'll leave it in a state that it's saved, but it is not submitted. Okay, all right, so that's how a homework looks. And then when we come along and look at the, let's go back to here. So let me content. So that's a good example of I clicked and got lost. So I'm going to come back to content, and I'm going to go module 1. And so then you do the watch the videos, you do the homework, you watch the videos, do the homework, and now all of a sudden there's a lab. And so you click on this lab description, and it's going to download this pretty significant lab exercise book. It's 200 pages, and it's got all 13 chapters of my textbook written up. So it has lab exercises. But we're only going to do the first 7 chapters. So when you come down into this, this gives you the handout of exactly every lab. And so, for example, if I come and I look at lab, here's the parts list that comes in your parts kit. If I come down here and look at lab 1.1, it's going to give you what are you going to do, learning outcomes, parts needed, and how you're going to deliverable, or what your deliverable would be. So then you are going to do these, and you'll upload these to the assignment folder. And so you see here, it shows you how to set up your breadboard. It's going to show you about resistors. It's going to show you how to do this, and it's going to walk you through how you do these. And in this first lab, you actually get all your equipment working. You have this little portable arbitrary waveform generator. You're going to make an LED work or blink. And then you're going to take a measurement of it, you're going to take a measurement of it, and just to show that everything in your lab kit is working. Every lab also has an overview video. So if you click on these overview videos, and in this one, I'm actually like walking through, showing you exactly what to do here. And so you want to use a combination of the two, but it's kind of neat to watch me actually walk through and do the lab. Okay, and so I don't do the lab completely, but I almost do. I kind of scaffold the whole thing for you. So you have videos on each one of those. And then, like I say, what you're going to do is you're going to upload that to the assignment folder. So if I click on assignment folder, it'll actually take you to a place where you upload the deliverables. And every handout will show you exactly what I actually want for the deliverables. Okay, so that is the course. And so now what I want to do is I want to leave you with one last set of tips. Okay, so you're in an online learning environment, and it can sometimes be a little challenging. You're alone, honestly, but remember that you're not alone, really, because you have a real teacher. So it's like I'm a real teacher. Stephanie's a real teaching assistant. We're here. We're teaching the course. You can email us anytime. You can call us. You can video call not anytime, but I'm here 8 to 5. Stephanie can probably be available after that, but we are here to help you. In terms of managing your workload, this is a 4-credit class. So if we were, in a regular semester, we would meet 3 times a week for a lecture for an hour, and then we'd have a 2-hour lab period. So if you think about that, using the rule of like number of credits times 2 to 3 for a semester, it's about 8 to 12 hours a week during a regular semester that lasts 15 weeks. And so now we're only doing this for 12 weeks, and it is a little bit on the low side because this isn't a terribly complex class. It's not calculus based. So what I've come up with is I recommend that you spend 10 hours a week on this class, okay? 10 hours a week for the 12 weeks of this class. The other tip that I'll give you is don't try to jam that 10 hours in one day. The people that really succeed well in this online environment are people that log in about 5 times a week. You can do it every day if you want, but I recommend that at a minimum you log in 5 times a week and make progress on there. That way you break the class up into like 1 to 3 hour chunks, dedicate time, log in, and actually chip away at it. The other thing that's going to be really important is that you check your email. So after you do that email etiquette extra credit, make sure that you check your email. That's how I'm going to communicate with you, and I don't want you to miss my emails. And so make sure that you check it every day following the guide and that etiquette guide. Okay, now here's kind of the biggest and the last thing. Don't stay stuck. When you're building these large circuits on a breadboard, there are times where it's not working and you can't see it. And no matter how long you stare at it, it's not going to get better. And so people that struggle tend to be the ones that are like, I'll just keep staring at this. I'll just keep staring at it. And 8 hours go by, 18 hours go by. You stay up all night staring at the circuit. Or even worse yet is you just start ripping your circuits out and putting it back together again. Rip it out, put it back together. And you're just repeating the problem. And so don't stay stuck for long. I would say in general, if you are stuck on something for about 30 minutes, and what I mean by stuck is that you're not making any progress. You're working on something and you're not making any progress. It's okay to work on something for 30 minutes or an hour or 3 hours, but as long as you're continually checking in with yourself and saying, am I making any progress, or am I just sitting here staring at the same thing and no new ideas are coming to me? So don't stay stuck for more than 30 minutes. At 30 minutes, here's what you should do is either, number one, call it a day. Okay, so either just go back and do something else and then come back tomorrow, or go take a break and come back, because your brain is not going to get itself out of this loop that it's stuck in by just sitting there. So change it up, just think about something else, or that's when you reach out for help. So leave us an email and then we'll get back to you, or set up a video call so that we can look at your circuit. So this is probably the most important lesson of online learning, is knowing when you are stuck. And it's just thinking about, it's actually called self-determination theory. It's when you're trying to self-monitor how you're progressing on an activity and you're alone. So it's totally up to you to make sure that you're making progress. It's not like you're in a live class where I notice that you're stuck and I come over and I go, hey, I see you're stuck. This is where you have to do it by yourself. So to really be aware of when things start feeling like they're not going good, look at how much time has passed, and at 30 minutes, stop and reset it. So go to sleep, do something else, send an email to us and take a break from it, and then come back and hit it again the next session. All right, so that is it. I look forward to working with you this summer, and we are off and running.